So here's going to be an example of how do we use stoichiometry in our calculations. So here's an example. How much ammonia can I make with 10 grams of H2? So you're starting with 10 grams of hydrogen gas and you're trying to figure out how much of NH3 that you have. So you have to use all the skills that you have learned so far. The first thing is we cannot just convert this 10 grams to use the molar ratios like 3:2, you're not going to have 15 grams. You can't do that because grams are going to be different for every compound. Remember, they all have different masses, right? So the first thing that you have to do, the first common common conversion unit that you can use is mole. So you have to convert your 10 grams and you have to convert that into your mole. So that's your first thing that you have to do. So in order to convert that grams, well, you need your molar mass, right? So what's the molar mass of H2? Oh, this one, hydrogen, is a pretty relatively easy one. So I'm just going to round this off to 1.00, 1 gram. And because I have two of these, I should really change this to 2 grams per mole. There we go. There should be a 2 grams per mole. So here's my first conversion factors. 10 grams times 1 divided by 2 by grams, so cancel out. I think hopefully at this point conversion is a pretty straightforward thing. So then you're going to get 5 moles of H2. Because the next thing is, well, you have 5 moles of H2 now. And the recipe here in the reaction says like it's a 3:2 ratio. So you have to convert using this ratio. How much of NH3 would you have if you have 5 moles of it? Another way, one way of doing this really is using your conversion factors. Same thing. So you can just do times division bar. How I do this is that because you're starting with moles of H2, so I'm going to get rid of this moles of H2. So I'm going to have moles of H2. And I'm trying to find moles of NH3. So I'm going to have moles of NH3 up here. So you notice this moles of H2 will cancel with the moles of H2. And I have moles of NH3 at the top. So then what numbers do I put in? Well, because these are my molar ratios, I'm looking at the coefficients in front of these compounds. So I'm going to have 2/3. That's my conversion factor. That's my ratio. So then I'm going to multiply this. So I'm going to have 5 times 2 divided by 3. If I can do my math quickly in my head, this is going to be 10/3. So that's going to be what, 3.13. Let me just quickly use my calculator here just to be exact. So 10 divided by 3. Let's see if my math was good. 3.3. There we go. So my answer here is 3.3 moles of NH3. But my question is asking how, well, I guess this question is just asking how much. But let's say that this question is asking you how many grams or how much ammonia in grams. So then I would have to convert this back into grams. So I'm going to rewrite this over here, 3.3 moles of NH3. I need to convert this to grams. So I'm going to have moles here and grams at the top, right? That's how I'm converting moles to grams. Now I need to find the molar mass of NH3, so I'm going to do this in my head very quickly. So 14 is for nitrogen plus 3 because there's 3 hydrogens which are all 1 grams per mole. So that gives me 17 grams per mole. So this is obviously it's rounded off. So I'm going to put 17 grams for every 1 mole. Notice my moles will cancel out. So it's 3.3 times 17. Let's go and bring up my calculator. 3.3 times 17, and that's 56.1 grams of ammonia. This is how much I can make, how much ammonia I can make with 10 grams of H2. That seems quite a bit, hey? Because that also will depend on how much nitrogen that I'm going to use as well. But that's how I convert it. I started off with converting my 10 grams of H2. I'm converting this into my moles, so 10 grams to 5 moles of H2. Then I have this H2. I need to figure out how much of NH3 I need, how many moles of that. I use my molar ratio, and I converted this to, I figured that out to 3.3 moles of NH3. and then I converted my moles into my grams. So that's an example stoichiometry question. The next one here is a little bit more complicated. You can see that this is my scenario. An orange precipitate of iron 3 hydroxide is formed when iron 3 chloride reacts with sodium hydroxide. So this is my sodium hydroxide, this is my iron 3 chloride, and this is my iron 3 hydroxide, and I get sodium chloride as a spectator ion. So here's my unbalanced equation here, and first off is that I need to balance this. Right now my elements are not balanced. So what I need to do is I need to see that, okay, let's start off with my polyatomic. I have 3 hydroxides, so I'm going to put 3 here just to balance off my OHs. But because I put 3 here in front of the NaOH, I'm going to have to put 3 here in front of NaCl to give me 3 NAs, but also affecting my Cls. But you can see that because I have 3 Cls here, I have 3 Cls here, I think everything is balanced. So this is going to have a 3-1-1-3 ratio. So the question here is calculate the number of moles of OH3 that forms if 26.9 grams of sodium hydroxide reacts. So I'm going from 26.9 grams, and I need to go into iron 3 hydroxide. So you can see that this one takes multiple steps. First thing I need to do is always convert everything into moles. So when in doubt, I'm going to convert this into moles. So I have 1 mole, and this is for my sodium hydroxide. So I need to find the molar mass of sodium hydroxide, and if you add up all of this stuff, Na is 23, this is going to be plus 16 plus 1, and sodium hydroxide has a lovely number of 40 grams per mole. So this is 40 grams per mole. So my grams will cancel, and I'm going to bring up my calculator, and let's punch this in. 26.9 divided by 40, and I'm going to have 0.67, let's round it off to 3 moles, and this is for my NaOH. So now I have the moles for NaOH. So that because I'm trying to look for the number of moles of FeOH3, I need to use stoichiometry. I need to use these molar ratios that's in front of these compounds. So how I set this up is exactly just like your times division bar. I'm going to put 6.673, and this is for my moles of NaOH. And then my times division bar, what I need to get rid of is moles of NaOH. So this is my moles of NaOH is at the bottom. I'm trying to find the moles. Luckily, this is looking for moles. I don't have to go another step. I'm going to have moles of FeOH3. Then these numbers that go in front of it are my molar ratios. That's the coefficient. So I have 3-to-1 ratio. So if you look at this, 3 goes beside NaOH. So this is in my denominator. Iron 3 hydroxide is going to be at the top, and you can see that I'm going to be basically dividing this by 3. So let's put it into my calculator. This divided by 3, that's going to give me 0.224 moles of FeOH3. That's my final answer for this question. I use molar conversions. I use stoichiometry to get to the moles of another compound, and that's my final answer. I can also, using this moles of iron OH3, if this is an extension, I can convert this to multiple things, right? I can convert this to the mass of that. I can convert this to the number of maybe particles or molecules of this. I can, if this were to be a gas, I can convert this to the volume. So this is how you tie in all those skills together. And to finalize, to summarize this is a good sort of a diagram to give you a visual aid of how to do this, right? On the one side, you have the substance A. So if this is one substance of the reaction, if you're given mass, remember mass has to go into moles. If you're given volume, it has to go into moles. Particles go into moles. So before you do any conversions, start off converting to moles first. And then after that, then you use the balance equation, the coefficients, the stoichiometry to find the moles of another molecule or another compound of substance B. So that doesn't mean that has to be in the product side. It could mean another reactant that you want to figure out. And once you have the moles, if the question is asking you to find mass, then you can convert to mass. If that's converting to volume, you can do that. And particles, you can also do that as well. So this is a good sort of visual to give you a hand if you need that extra help. Hopefully these couple questions has helped you, and hopefully your understanding of stoichiometry has improved. Thanks for watching.